This is video 2.2c, the final video about graphing absolute value functions. In this example here, you'll notice that it looks a little bit different from what you saw in the previous examples. We have a value inside the absolute value, which changes the vertex. So when you have a problem like this, I'm not going to ask you for all the transformations. I'm not going to ask you, for the domain and range. I'm just going to want you to graph this function here. Now, when you have this, your vertex is going to change. Your vertex is no longer HK. Okay, this is what you've been used to. It's no longer this, it's changed. So one thing that you have to understand is what happens, right? So the vertex occurs when the number in here, what's inside the absolute value sign, is equal to 0. So in your previous examples where you had a times x minus h plus k, your vertex occurred when x minus h was equal to 0. So x minus h equal to 0, so you would add h to each side, right? So x is equal to h. This is why, your sign came out opposite, right? So it's negative h here, but in reality it's a positive there. So we're doing the same thing, except now we have an extra number that we have to deal with. We have, let's call it mx minus h. Okay, so if we want to set that equal to 0 and solve for h, we can, or for x, excuse me. So you would add h to each side. And I'm just showing you the math behind this, guys. So you can kind of see what's going on. So then you would have mx is equal to positive h. And then to solve for x, you would divide by m here. So that x is equal to h over m, whatever that value is. So one thing that you need to know is this is going to be negative. So you do the same thing here. If you want to find the vertex, okay, you have to solve for x first. So we're going to have 3x minus 4 is equal to 0. So the same thing, just solve for x plus 4 on each side. We're left with 3x is equal to positive 4 divided by 3. And so the x value of your vertex is going to be the fraction 4 over 3, okay, or 1 1/3. Okay, so approximately 1.33. And then your k value is going to be the same because it's on the outside. So it's still plus 5. So your vertex is at the point 1.3, or you can put 4 over 3, it doesn't matter, and 5. I like approximating the fractions to decimals so it's easier for you to plot on the graph. Okay, so you can see exactly how much that is. Okay, so if we want to graph this, we would go to the point 1.3 and 5, so up here. So that's our vertex. Okay, and then the same thing, your axis of symmetry is going to go through that point 1.35. And then your axis of symmetry is going to go through that. That's the line x is equal to 1.3. Okay, that's your axis of symmetry. And now we know that it is going to be reflected, okay, and that the slope is still -1. Okay, so -1 over 1, down 1 over 1. Okay, so around here, down 1 over 1, down 1 over 1. Okay, so there is your graph of that function. You could also plug this into the calculator to check your work. On your exam, I'm not going to ask you to graph something like this without a calculator. Okay, You should also be able to find your domain and range of this function. Okay, so your domain always all real numbers. Okay, your range is a little bit different. We have a maximum at this point here at y equals 5. Okay, and then our minimum, you see that it keeps going down to negative infinity. So you have negative infinity less than y less than or equal to positive 5, or y is less than or equal to 5, okay, or in interval notation, negative infinity to 5, close bracket there. The other thing you need to know how to do is to write the equation from the graph. Now, I'm not going to give you anything complicated like in the previous example. If I give you a graph and I want you to write the equation, I want you to write it in f of x is equal to a x minus h plus k. So the first thing that you need to do is identify the vertex. Okay, so if we're looking at this first example over here, our vertex is right there. That's a minimum at the point -4, 2. Okay, now remember that's your h and that's your k. And all you have to do is plug it into the equation. The next thing you have to do is find your slope. So just pick another point on the graph and find your rise, which here is 1, and your run is 1 as well. So 1 over 1 is just 1. Okay, and the positive direction, it's opening up. So all you have to do is plug them into your equation. So you have a is equal to positive 1, h is equal to -4, and k is equal to 2. So you plug them in. A times the absolute value of x minus h plus k, which is positive 2 here. Okay, so f of x. And then you just simplify that. So the 1 is just going to be 1, so we have f of x is equal to 1 times the absolute value of x, and then this double negative here becomes a positive, so x plus 4, close that absolute value, plus 2. Okay, and that's the equation to that line there. Do the same thing over here with the one on the right. You identify your vertex, that's your maximum there. So that's at the point 1, 2, h, k. You pick another point on the line, it doesn't matter which one you pick. So we are going down 2, so that's a -2 for your rise, and then we are going to the left 2. So you see that your slope is 2 over 2, which is 1. Okay, but because it's opening down, you should know that it's a -1. Okay, it's reflected in the opposite direction. So this is your A. Okay, we have your h and your k, and you just plug them in. F of x is equal to -1, or you can just put the negative, it doesn't matter. X minus your h plus k. I use parentheses so that you can catch any double negatives, which will only happen inside the absolute value. X minus 1 plus 2 is your final answer. Okay, if you have any questions, let me know. Shoot me a remind. You have my email, or ask me in class when you see me. This is your last video for Chapter 2, so you should finish up the quest homework as well as the worksheets that are online for the 2.2 assignments, and start getting ready for our exam. If you have any questions, let me know.